Okay, I have over here
It's beautiful.
the Eiffel Tower. Thank you
Oh
very
my
much.
That's the
god.
best drawing you've made here. I think it is. I knew what it was. Like,
Yeah, like it's actually it's pretty. Like it's a good
I think
Okay,
Ben's gonna
it's
have
serving
to-
its
Whoa, and now it
purpose
has
well,
Gravity.
and now it has ground.
Good
Your
job.
architecture
Okay.
B minus, but A plus forever.
It's still two-dimensional.
So you
Okay,
have it.
okay, shush, you lot. So what we have here is a person is trying to measure the height of the Eiffel Tower. I'm doing 8.2, number 35.
Well, the person's stupid.
No, they're not stupid. This is how you do things. So this is how you actually measure mountains. Right?
Yeah.
Because you can't like drill a hole to the bottom and then drill a hole in from the side and then like fish a tape measure through it, right, to get a right triangle. So what you do is you look at it from one distance and then you back up a little more and you look at it again and then measure the distances between the spots you look.
Makes sense.
And then you solve this funky triangle.
Oh.
So what we have here is first person has here a 60-degree angle,
Which means that's curved.
which,
Supplement is going to be 1 point.
whatever. Okay, so 60-degree angle to the top of the tower, moving 210 feet closer. So they move this way 210 feet. Now they're standing over here, and the angle is steeper, right? Now it's 70 degrees.
And the supplement of that is 1 time.
So basically I'm interested in what's the triangle that I'm solving here.
The one that uses the 210 as the bottom of the,
Yeah, so I've got 210, I've got a 60 in there,
and then a 110.
and then there's not a 70, there's the opposite of 70, right?
110.
So I have a 110 in here.
Which is not really the opposite of 70, but
It's the
supplement of
complementary
70.
angle.
Complementary.
Or it's the supplement, right? Not the complement.
Supplement? No, supplementary.
See, the reason that I'm not using those words is I can never
Complementary
keep
is-
track which one's adding to 90 and which one's adding to
No,
180.
90 is a compliment because
yeah,
it's a good.
yeah,
It's just a good compliment to be
And-
right.
Yeah, that's
You know, the thing is, I don't even really care.
Yeah.
I just
It's
need it to add up
supplementary.
to 180
Yes.
because it's a line, right?
Yes. Yes.
It's
yeah,
supplementary.
Yes. You're right. Ultimately, it's
I suspect that it's supplement, but I don't want to commit to that because I'm not sure.
You should
And
commit
And
to that
now,
because we don't.
160 plus 110,
Okay, so now you know that 60 plus 110 is
170, and
170.
80 minus 170.
170, so that means that this angle up here is 10 degrees,
So true.
Or just logic and
or just logic and whatever.
yeah.
Okay, question. Which thing do I need to figure out how high the Eiffel Tower is? Because that's
The
not in
longest.
my picture.
The longest side.
You guys see that? Like, this is the thing that I'm interested in.
Yeah. So you need to find the distance between that and.
So,
I need to find one of the hypotenuses.
I need to find a
Hypotenuse.
hypoteni,
One of the hypotenuses.
one of the
Oh.
hypotenuse.
You need to find the hypotenuse. You need to find the hypotenuse. of
So,
the-
either of these two sides is available for grabbing. I don't care which one you get, right? I'm going to use this. What am I going to use after I get a hold of that?
You're gonna use sine.
Yeah, specifically I'm going to use sine, right? Because I'm interested in an opposite side.
Right.
And then I'm either going to use this bigger triangle or the smaller one.
Right.
But either way, I'm going to get one of the right triangles.
Yeah.
You guys with me on that?
Yeah.
So the first thing I need is to find this guy. That's my goal.
All right.
Well, the sine of 60 degrees.
Okay?
So yeah, we're actually
No,
we're gonna do cosine of 210 over x. Or 210 over
It's not a right triangle. You can.
The law of sine.
Yeah, exactly.
Okay, why do you want to use the law of sines and not the law of cosines or a cosine or a sine? So
Because it's
first,
not right.
why not law of cosines?
Because we have an angle side angle.
You have all. the
Okay, but
angles.
that doesn't help me.
Because you have all the angles, and you have a side.
You have one side.
that correlates to
With an angle.
and the other angle without the side that correlates to.
How about for a law of cosines, what do you need?
I know.
You need lots of
Two
sides.
sides and the angle in between those.
Yeah, you need two sides and an angle to make that thing work. I don't have two sides, I only have one of the sides. You guys see that?
Yeah.
So if you only have one side, you need the law of sines.
Okay.
Why can't you use a sine or a
not a right
cosine? Just
triangle.
raw?
This is not a right triangle.
Because it's not a right triangle. So,
Why are you like
if you use the law of sines,
Wait,
which
it
thing do
is-
you want on top? Sine of angles or side lengths?
It doesn't really matter,
Really-
but just make sure you stay consistent.
Not cause.
It doesn't really matter. I'm going to put that question mark on top.
Okay, so question mark over the sine
Over-
of 110.
Sine of 110.
Sine of 110 degrees is
210 over the sine of 10 degrees.
210 over 10 degrees.
Sine
Right?
of 10 degrees.
Oh yeah, you need the sine.
That makes a big difference.
It does make a huge difference, right? Okay, so
Now solve for question mark.
question mark is 210 sine of 110 degrees over sine of 10 degrees.
Yeah.
Am I worried about weirdness with arc sines? Right, remember, I don't like using the law of sines because sometimes
No.
there's weirdness.
No, you're not worried. You're not worried.
Why am I not worried here?
Because you know the angle is 110 degrees.
Yeah, you know the angles. You don't need to take the arc sine of anything because you know the angles.
Yeah.
It's right.
Is with that?
Yeah, it's right.
What's wrong?
It's right. It's right.
It's right.
Going
It's
down.
right.
Okay.
Australian.
Don't make fun of Australians. What do you get? They're nice people, I'm sure.
1,136.41.
Cool.
1,100.
Approximately 1,136.
Cool.
Okay, next thing.
All right.
That
Now you
is
have the
the
hypotenuse
height.
of your right triangle.
Hypotenuse.
Okay, so now you should pull out a blue triangle.
Make sure you have blue.
Oops, not
That's
that one.
definitely not the right
An alright triangle then?
It's also definitely not the right one.
one.
Because
Right.
the one I need is this one.
Right, exactly.
You just ruined your marker now.
Why didn't I just use tangent?
They're both equal to that opposite. You could do tangent of, make the, for the 70-degree triangle,
Yes.
make that distance x.
This guy?
No, underneath, from the.
210 minus x,
Down there.
or 210
that's
plus x.
Okay.
And then you do tangent of 70 equals opposite over x. Right, and then tangent of 60 equals opposite over x plus 210. Then you solve them both for opposite, they equal the same thing, right? So you solve for x,
Wait. Oh, I see.
multiply both sides, so x times tangent of 70 equals,
You could skip the middleman and eliminate the x's too. Yeah, this would work. So this is another reasonable method that you could use. Or you could use this one,
yeah.
right? And at the end of this one, I would have the sine of 60 degrees is
Opposite over
That
1,000.
opposite side over 1136. Well,
Solve for op.
is approximately, right? Or there's probably yet more methods.
I don't think so.
Yeah, I'm sure there's a million more methods to
A
do this.
million.
I don't care which method you use. This is a cool trick. I dig it. Probably I would have done this one, just personally, but whatever. I mean, use whatever pops into your head,
As long as it's right.
as long as it's an appropriate method.
Right.
Whatever you do, don't do something silly like take the tangent of 60 degrees and tell me that that's the opposite over 210,
Yeah. That's so silly.
right?
Silly Willy.
As long as you're not applying these, right, the standard trig functions in a non-right triangle, we're okay. Don't do that. Cool? Questions, things? Okay. This used to be a legit thing that people would do to survey mountains
Okay.
from the ocean
That's pretty cool.
so that they could figure out which one they wanted to climb.
That's pretty cool.
This went back and forth in Alaska for a really long time, and there was a lot of money involved in the, like, I'm the guy that got to the currently tallest mountain in Alaska, and then you like hire a dude to survey a bunch of mountains and then figure out which one's actually taller, and then go climb that one.
Yeah, makes sense.
But of course, that's predicated on the fact that you can see them all from the water, and of course, you can't see the tallest ones from the water. Whoops.